Bismillahirrahmanirrahim. Today we will start our first experiment, which is facing using CNC Simulator. Simulator is used with G and M coding, which we will discuss and learn today. Before working on actual CNC lathe machine, we will run our program on CNC Simulator. So if there is any error, it can be pointed out with the help of the CNC Simulator. So you can see that this is the benefit of engineering, that before working with actual workpiece and actual environment, we can predict our results with simulation. And if there is any error, we can remove it before. Facing is the process of removing metal from the end of the workpiece to produce a flat surface. Sometimes the end point of the workpiece are not so good, so they may be irregular in shape. So by facing we can remove that part from the workpiece and then machining process can be applied. Normally cylindrical objects are used, but with the help of four-jar chuck we can also do the facing operation on rectangular or odd shape work to form cubes and other non-cylindrical parts. Facing basically reduces the length of the workpiece. Now, this is our workpiece required of dimension 90 mm, and this is our raw material with dimension 100 mm. As discussed earlier, in facing, we decrease the length of the workpiece. Now you can see that here we have reduced or decreased our workpiece length from 100 mm to 90 mm. Here you can see the difference in both parts. Also you can notice that in both parts the diameter is 40 mm. So in facing there is no change in diameter, only the length is decreased. Now starting with the CNC simulator, first you will open the CNC simulator software. Then you will click on the top right side on the icon File Manager. Then this window will appear. Now there are three options you can see. The Open Project is option used to continue work from previous session. I mean, if you have already a job saved, you can open it from this option. The Save is for saving the current progress, and New Project is for starting new job, as we are doing here for facing operation. So we will start with the New Project option. After starting the new project, you will set now the workpiece parameters. For this, you will click this icon here, second right top side. This window will appear. Now this is the workpiece length. This is the initial length of our raw material, which I have set 100 mm. This is the workpiece diameter, which is the initial diameter of our raw material, which is in this case 40 mm. This is the clamp length. Clamp length is the length inside this chuck. Here you can say the length of the raw material inside this chuck is known as the clamp length, which I have set 20 mm for good clamping. We have set all the initial parameters of our raw material: 100 mm length, 40 mm diameter. All these are the initial parameters of our raw material before facing operation. After setting the workpiece parameters, now you have to select the tool parameters. For this, you will click this third icon in this figure. This is for the tool selection. When you click this icon, this window will appear. Here you can see you have different options for tools. For turning, facing, there are different tools. Now in this case, we will select this 5 number tool, which is for journal, turning and facing. For selecting the tool, you have to drag the tool like in this way. From here you drag the tool this like and put it there. By doing this, you have selected now the 5 number tool, which is for journal, turning and facing. We have no need to change these parameters of the tool. You can see that there are options for selecting other tools like 2, 3, 4, 5. These are used for selecting multiple tools. Like you have studied that in tool pose, multiple tools can be adjusted at one time. So this option is used for selecting multiple tool selection. Now before starting the coding, I will summarize up till now what we have done. First, we have opened the CNC simulator. Then we have opened a new project. Then from here we have set the workpiece parameters, this option. Then from here we have selected the tool. I think I missed this highlighting option in the previous slide. So this is the third option for selecting the tool. Now the fourth option, this is used for the coding. you have to, when you will click this icon, a new window will appear like this. I have written the code, but when you will click this icon, there will appear a new blank window. Okay, then you have to write the code for the facing operation, of what operation you have to do. I have explained this coding in the later slides, but here I will tell you, for every code there are three parts: the first part, the middle part, and the end part. This is the first part of the program, like the from here this line to this line. This is the first part. This is the middle part from this line to this line, and this is the end part from this line to this line. The first part of the program is generally used for switching options, like which units you are going to use, metric or inches, similarly to switch on the coolant. While the middle part is related with the workpiece details. You will define workpiece here, like its length, diameter, which option you have to perform. All these details will be written here. In the end part, you will now close the program, and other things like if the coolant is on, you will write the command here for switching off the coolant. Similarly, M30 is used like this line, it is used to close the program. For writing the program, you can use your own keyboard, and also the simulator on option for writing can be used, which I have discussed in detail in the coming slides. This is the keyboard of CNC Simulator software I was talking about in the previous slide. This is the icon in the bottom taskbar. By clicking this icon in the bottom taskbar of the CNC Simulator software, where the writing code option is, this keyboard will appear. As you can see, this keyboard covers almost all the required alphabets, and all numbers are present in the keyboard. Also, other necessary buttons like enter, delete, and backspace is also present. Here, brackets are also present. So you can see you can use this virtual keyboard of CNC Simulator, or if you don't want to use this, you can use your own laptop or a computer keyboard. It's up to you which keyboard you want to use for your own comfort. This is the complete code for our required task, in this case the facing operation. I will explain this code in the later slides. For every code, for every line here, there is a specific operation. I will discuss in detail in the coming slides. For every alphabet there is a specific task, like G, N, X. All these alphabets represent a specific task, which I will discuss in the next slide. Now, starting with the code explanation, I will start with the very first line, which was 0001. This line is the start with the code O, and it O 0001. While writing a program on Funi controller, first line has to be start with O letter. It will always followed by a four-digit number. The number specifies from 0001 to 9999. This is the range of the its own code. Whenever you write a program, it always have to be specified by specific number. So in the very first line, we will specify our program code by giving it a specific number. Now I will describe about G54 code. Here it is written in the second line. G code is always used for machining operation options. Talking about G54 code, it is used to switch between different coordinate system. For example, if initial working coordinates are different than our required operation, we will use G54 code. It will come to the By using this code, it will come to the current working coordinate system. So this is the use of G54 code. Now talking about the Z minus 10 code, here it is written, it is used to control the movement of the tool. Like we have discussed, we have to decrease the length of our workpiece by 10 mm. Let's suppose this is our workpiece. Okay. Now when you will give the command of minus 10, let's suppose this is our tool here. Now what it will do, the tool will move from this point to this point here to the end of our workpiece. Now by giving minus 10 mm Z, now what tool will do, the tool will move in the negative 10 direction, means from this point to minus 10 mm, this point. It will limit the movement of the tool. Initially we have decided to decrease the length of our workpiece by 10 mm. So by using z minus 10 mm, what we have done, two things. The tool has moved from this point to, I am sorry for the last slide, it was discontinued, that's why I had added it again. I was explaining you the purpose of z minus 10 command, this z minus 10. Z direction is normally in parallel to the headstock. Let's say this is your workpiece. So this is the Z direction in the direction of the workpiece parallel to the headstock. This is Z direction. What does Z minus 10 mean? Z minus 10 means when you give the tool Z minus 10 command, it will move. I'm selecting red color for your understanding. It will move minus 10 in this direction, negative Z direction. Let's say up to this point. As in the earlier slides, we have selected the code for the removing the length from 100 to 90, for decreasing the length from 100 to 90 mm. So this minus 10 is the decrement in the length in the negative direction with respect to the tool. Tool will slide in the negative direction, Z direction, up to minus 10 mm. Tool will slide in this direction, and for y direction, tool may move in this direction perpendicular to the workpiece. So you can say that the z and y direction are perpendicular to each other. Now moving towards the next line, this is the N10, G21, G99, G40. Starting with the N10 line, whenever N code is used, it is used to define the name or title of block of G code. Or simply, it defines the line number. So N10 means N line number 10. The next is G21. G21 code is used to switch between the metric system of units. So when we have used G21 code, so every dimension written in the code will be considered in millimeters. It is used for metric units in millimeters. G99 code G99 code select the units of the feed rate. So whenever in the code you have given the feed rate, it will consider it in millimeter per revolution. So we can say that we have now set our units in millimeter, and we have set our feed rate in millimeter per revolution. Every value you give in the code, the length of your dimension will be in millimeters, and the feed rate will be taken automatically in millimeter per revolution with the help of G21 and G99 code. G40 code is used for tool radius compensation. There are two other codes, G41 and G42, for left and right tool radius compensation, but here with the help of G40, we are selecting automatic tool radius compensation. Now the machine will our CNC will automatically select the tool radius compensation according to the our tool and workpiece. Now discussing about G00 code. This code is used for the rapid G00 code is used for rapid positioning of tool. For example, if the tool is away from the workpiece, by using the G00 code, the tool will rapidly position towards the workpiece. This is the purpose of G00 code. G28 code G28 code is used to move the tool to a reference point. Initially, we will set a reference point for the tool. So when we use a G28 code, after the work is finished, the tool will move to its reference point, which we have set earlier. U0 and W0, these are the secondary movements about Z and Y axis. These are used to move the tool in the X and Y axis according to our positioning. Now starting with the next command, this was T0101. Normally T command is used for changing of tool. As we have discussed earlier, there are a number of tools, almost 4 tools can be applied at different tool posts. So T command is used for changing of tool. Here the first two digits 01, it represents the tool number 1, and the second 01, this number represents the offset number. It means we have tool number 1 at one position. I am calling my tool which I have numbered in number 1 position to offset number 1 for the facing operation. So whenever T command is used, it is used for changing of tool. It can be 01, 02, 02, 01. Different tools at different numbers. Always remember the tool position for calling the specific tool for specific operation. Like I have installed my tool at first position in the earlier slides, so I am recalling it from the first position. The next line is G96. G96 is used to rotate the spindle at constant RPM. So here you see the next code is S500. Both commands together means now the spindle will rotate constantly with the RPM of 500 revolution per minute. The rotation unit revolution per minute was selected in the previous slides. The next is M03. M03 is used for selecting clockwise rotation. Its opposite is M04, which when applied the spindle will rotate in anti-clockwise direction. Now next, these are the initial points X42 and Z8. For explaining these, I will first draw here the, let's say this is our workpiece. Now what this X42 and Z8 means, X42 means, let's say this is our workpiece. Oh sorry, this is our tool in this direction. Remember that our workpiece diameter was 40 mm. Now X42, this gives the clearance of 2 mm. Here you see there is minute clearance between red and yellow portion. This is the clearance of 2 mm. Let me choose color, black color. Uh, Here, oh sorry. Uh, you see that there is a clearance of 2 mm in the between tool and the workpiece. So this is the initial point for tool in X direction with the clearance of 2 mm. X42 commands gives this clearance. Now Z8 command, Z8 command, remember we have given Z minus 10 in initial slides. Let's say this is minus 10. So when you give Z8, the tool will move in the right direction Z8 in, let's say, in this direction up to this portion. Again there is a clearance of 2 mm. Now what we will do, we will cut our workpiece in multiple attempts of 2 mm, not in single attempt, because in single attempt it can heat up the tool and can damage the tool. So we will use the clearance of 2 mm and we give the tool the cut of 2 mm in the Z direction. So we will do the 10 mm cutting or decrement in length in multiple attempts. And now the next is G94 code. G94 code is used for facing cycle. Let me on the G94. G94 code is used for facing cycle. As we have discussed, we cannot cut our workpiece in single attempt. So for multiple attempts, instead of giving values again and again, we will use G94 code. We set values for X and Z axis initially. G94 code covers the following parameters like rapid to Z position, feed to X position, feed to start Z position, and rapid to start X position. All these parameters are discussed in the next slide with proper values for our facing operation. Here you see this is the proper G94 code with proper values for X minus 1, Z 7.5, F 0.3. Now I will explain these values. First one is X minus 1. This is our workpiece. I have drawn it already. I will draw the axis here. Let me draw the axis. This is your Z axis. This line. This is Z axis and this is your X axis. Both are perpendicular to each other. Let me write this. This is Z and this is X axis. Sorry for irregular X. What does X minus 1 means? X minus 1 means this is the center, let's say center of the workpiece, X minus 1. The center is always set at 0. When we give the tool X minus 1 command, the tool will move in this direction, X direction up to 0 and beyond 0 minus 1. I have selected minus 1, so it will confirm the smooth cutting of the workpiece. It will go beyond 0 like minus 1 there. Now your spindle is rotating, so and tool is moving in the X direction. It will cut the workpiece in the perpendicular direction to the Z axis. So X minus 1 means cutting in the X direction while rotating the spindle. Now discussing about Z 7.5. Let's say this is the 10 mm. Now this line from this point to this point, this is 10 mm. As we have discussed earlier, we will cut the workpiece in multiple attempts. So let's say these are the points 1, 2, 3 and 4. Let's say it is 0. Now Z7.5 means initially the tool will move in Z direction. As I say, this is the Z direction, this is Z direction. Now tool will move in Z. Let me choose yellow color for this. Uh, this is Z direction. Now tool will move in Z direction from 7.5 to 5 mm. Initially it will cut from this point to this point, this point. This is 7.5. Again for next cycle it will cut it from 7.5 to 5. This is 5 mm. Then again it will cut the workpiece from 5 to 2.5. This is 2.5 line. And for final cut it will cut the workpiece from 2.5 to 0. This is the 0 line. So in the 4 attempts we have cutted our workpiece for a total of 10 mm. Each cut was of 2.5 mm, which we have given in multiple attempts. I hope so you have got it. And let me again summarize. Our spindle is rotating in clockwise direction. This is our workpiece rotating with spindle in clockwise direction, and tool is moving in x and z direction. Uh, X is this direction, this is x direction, which we have given value of -1. From -1 is away from center. Tool move in this direction from center to -1 mm away, and z is this direction, this is that direction in which tool cuts the workpiece in multiple attempts. So it will cut up to 10 mm length from the right hand. From right hand to this direction, the workpiece will cut the tool will cut our workpiece and giving us the decrement of 10 mm in total length, which was initially desired to bring workpiece from 100 mm to 90 mm. Now the next is f0.3. F is basically the feed rate, which I have selected 0.3. It means the feed rate is now 0.3 revolution per minute. And M code is used for machine code. It is used for machine different purposes, like M08 here is used for turning the coolant on. So this is the complete G94 code, which I have discussed in detail with feed rate and M08 for the coolant turning on. Now coming to the end of the program, as discussed earlier, there are 3 parts of program. First part was the initialization, which we have set, then the middle part in which we have written all the code including G94. Now the end of the program. At the end of the program, the first one is G00. G00 gives the rapid linear interpolation position to the tool, means it moves the tool away from the workpiece to a specified position rapidly. Z10, it is similar. The tool will move 10 mm away from the workpiece in the positive Z direction, means it again moving the tool away from the workpiece. And M09 is used for turning the coolant off. In the previous slide we have used M08, in which we have turned the coolant on. Now in M09 we have turned the coolant off. G28, if by chance if you have not used G00, and then G28 reference point returns the tool first to G00 position. This is often known as intermediate position to which tool is done. Then after G00 it will go back to the home position. Here reference points U, W, these are along about X and Z axis. I have selected both 0, 0. So the tool will now return to X0 and Y0. At the end there is M30. M30 is used for the completion of the control program. It is always used at the end of the program. Now here our program is complete at M30. So far your coding is complete, your program is complete. Now we have to run the simulation for checking if any error is there, we can notify it. There is the play button. From here you can run the simulation. So if there is any error, it will be notified. As discussed earlier, before working, we will run the simulation for checking the error. Here is the pause and stop button. If you want to pause or stop the program, you can use these buttons. And this bookmark icon, this is used if you have any confusion regarding any code, then click this icon. The detail for every code will be available to you for checking of any code or any other information regarding the code. Up till now, your work is complete, your code is complete, simulation has been done. So now we have to save the project. Again, click the topmost icon in the right side. By clicking this icon, this window will appear. Here you will click the save project. By clicking this option, you will save the current all progress. Remember that don't use space in between the alphabets. Always use underscore sign because the space sign will not be read by the software. So use underscore sign in between the alphabets if you have to use them. Also in the next slide there is complete video for the program written along with running simulation. Each step is described live one by one for better understanding. So if you have any confusion so far, please see the video in the next slide recorded in Urdu. A video will give you the detail of every step with running simulation. And thank you.
अब पूरे होल प्रोसेस को समझाने के लिए आप यहाँ पे फाइल मैनेजर पे क्लिक किया था, ये आपने न्यू प्रोजेक्ट लिया था, यहाँ पे आप फिर गए। अब दूसरे नंबर पे आपने देखा ये आपने वर्क पीस को यहाँ से एडजस्ट किया, और एडजस्ट करने के बाद आपने इसके डाया को कम ज़्यादा कर रहे हैं। इसके अलावा क्लैंपिंग लेंथ के बारे में मैंने आपको बताया था, तो आप इसने 20 mm पे इसको क्लैंप करना है। इसके बाद आप जाएंगे अपने, आप ये आपके सामने वर्क पीस नज़र आ रहा है जो क्लैंप है 3 जाचक में। यहाँ से हम अपने टूल को एडजस्ट करेंगे। टूल पे जाएंगे तो ये टूल कैटलॉग में आपके सामने सारे नज़र आ रहे हैं, जिसमें हमने जनरल टर्निंग एंड फेसिंग टूल को ड्रैग करके नंबर 1 पे लेके आना है। तो इसमें हमने कोई चेंजिंग करने की ज़रूरत नहीं है, सेम एज इट इज़ हमने इसको सिलेक्ट कर लेना है। अब यहाँ पे हमारी ये पूरी विंडो ओपन हो चुकी। इसमें हम कोड को लिख सकते हैं बाय अपने कीबोर्ड से भी और बाय मैनुअल जो नीचे शो हो रहा है उससे। तो ये मैंने कॉपी पेस्ट कर दिया अपना पूरा कोड, और उसके बाद अब मैं इस कोड को रन करूँगा, स्टेप बाय स्टेप के देखूँगा कि ये कैसे रन हो रहा है। तो उसके लिए प्ले के बटन को प्रेस करूँगा, और अब मैं अपने प्रोग्राम को साथ साथ देख सकता हूँ। ये मेरा 3 जाचक जो है वो वर्किंग करना शुरू हो गया, ये मेरा कूलेंट ऑन हो गया है, और ये मेरा वर्क पीस इसको कर रहा है। यहाँ से मैं इसके एक्सेस को ऑन भी कर सकता हूँ, ऑफ भी कर सकता हूँ, अपनी वर्किंग ट्रेजेडी को ऑन भी कर सकता हूँ, ऑफ भी कर सकता हूँ। ये मुख्तलिफ कैमरे हैं इसके। तो ये अभी हमारी वर्किंग नज़र आ रही है कि टूल जो है वो 2.5 mm की जो मैंने कहा था उसकी लेके वो काट रहा है उसको। तो ये उस अपने टूल पाथ को फॉलो करेगा। तो 2.5 का एक उसने काटा, 2.5 का दूसरा काटा, और ये तीसरा एट द एंड ये 4 पास करेगा, और फिर आपका प्रोग्राम क्लोज हो जाएगा। तो हमारी फेसिंग का जो ऑपरेशन था वो ये पूरा कंप्लीट प्रोसेस था। अब आप ये देख सकते हैं विंडो में, पहले हमारा जो था वो ये रेड आपको नज़र आ रहा था, ये इनिशियल पॉइंट था। इस इनिशियल पॉइंट से हम अंदर तक गए और हमने 10 mm को रिड्यूस कर दिया। अब हम, ये आपको 2D व्यू नज़र आ रहा है वर्क पीस का, जो 100 mm लेंथ थी अब उसको हमने 90 mm पे कर दिया है। तो ये आपके सामने पूरा जो एक व्यू है वो सॉफ्टवेयर का बहुत जो है फ्रेंडली इन्वायरमेंट है, सॉफ्टवेयर का रियलिटी के करीब है। आपको इसमें जो है 3 जांचा कैसे वर्क कर रहा है, टूल कैसे करता है। ये हमारी पूरी CNC लेथ मशीन है जो हमारी वर्कशॉप लैब में सेम एज इट इज़ यही मशीन जो है वो अवेलेबल है। ये टूल है जिसने वर्कपीस को काट दिया। यह सारा प्रोग्राम के करने के बाद एंड की एक थोड़ी सी वीडियो है।